The question is given four systems with impulse responses and asking that which system is not stable. Okay, we know that the condition for stability of a system is sigma n equal to minus infinity to plus infinity mod h of n must be less than infinity. Then the system is said to be stable. If it is equal to infinity, the system is said to be unstable. Okay, let us take the first system. H of n equal to 1 by 2 whole to the power of n u of n plus 2 by 3 whole to the power of n u of n plus 1. Okay, let's substitute this in this equation. So sigma n equal to minus infinity to plus infinity 1 by 2 whole to the power of n u of n plus sigma n equal to minus infinity to plus infinity 2 by 3 whole to the power of n u of n. So this is equals to, it is multiplied with u of n. So 0 to infinity 1 by 2 whole to the power of n plus sigma n equals to 0 to infinity 2 by 3 whole to the power of n. So what is the value of this sigma n equals to 0 to infinity alpha power n? Value is 1 by 1 minus alpha provided that mod alpha less than 1 and equal to infinity when mod alpha greater than or equal to 1. So let us see this alpha here is 1 by t, is it less than 1? So this total summation value is less than infinity. Here 2 by 3 value is also less than 1. So total this summation value is less than infinity. So finally this value is less than infinity. So the first system is stable system. Let us see the second one. H of n equal to 2 by 3 whole to the power of n u of minus n. If you substitute that, sigma n equals to minus infinity to plus infinity 2 by 3 whole power n u of minus n. It is multiplied with u of minus n. So the limits are sigma n equal to minus infinity to 0 2 by 3 whole to the power of n. So this is equals to, if you replace in place of n minus n equal to 0 to infinity 3 by 2 whole to the power of n. Let us observe that here alpha is 3 by 2. It is greater than 1. If alpha is greater than 1, what is the answer? Infinity. So this is equals to infinity. So it is not a stable system. It is not a stable system. Let us see the third impulse response. H of n equal to minus 3 whole to the power of n u of minus n. If you substitute that, because of u of minus n, minus infinity to 0 minus 3 whole power n sigma n equal to 0 to infinity minus 3 whole to the power of n. Here alpha is minus 1 by 3. So the summation value is also less than infinity. So this system is also stable system. Let us see the last one. The last one is h of n equal to n into u of n minus u of n minus 10. This also you can written as n for n is ranging from 0 to 9 and equals to 0 otherwise. So if you substitute this value in this summation, it is going to give the finite value only. So the last system is also stable system. So the answer is B is the right answer. The question is, what is the minimum sampling rate required to sample this bandpass signal? So it is a bandpass signal. This is lower frequency FL. This is higher frequency FH. So the minimum sampling rate required to sample this bandpass signal is Fs minimum is equals to 2fh by k. What is k? K is the largest integer which is not going to exceed fh by fh minus fl. It is not going to exceed this fraction, okay? So fh value is 1.5 divided by 1.5 minus 1. This is equals to 1.5 by 0.5, that is equals to 3. So k is a value which is not going to exceed this value. So k is equals to 3. So substitute this fs minimum is equals to 2 into 1.5 by 3, that is equals 1 kilohertz, because the value is given in kilohertz. So the answer is 1 kilohertz. So the right answer is C. The question is, this is the signal given x of t with period t0. T0 period given itself in the problem. So what is the DC component of this signal x of t? Let us try to draw this signal first. So from the given data, x of t, so 1 for mod t less than d. Mod t less than d means minus d2 plus d. Minus d2 plus d, value is 1. Okay, next 0 for d2 t0 by 2. So d2 t0 by 2, it is 0. Okay, and the question itself is given that it is a periodic signal with period of t0. So I can write like this. So this is t0. 0 to t0 is one period. So in the same way, left side also minus t0. So this become minus t0 by 2. So it is the given signal. Okay, 1, 1. So what is the DC component of the given signal? DC component is nothing but A0. A0 is equals to 1 by T0 integration TA to TA plus T0 x of t dt. T0 is the period of the signal. So for this signal also period is T0. 1 by T0 integration minus d2 plus d 1 dt. If you solve this integration, 2d by T0 is a DC component of the given signal. So the right answer is C. The question is, what is the Fourier transform of x of t equals to 5 by 2t? Okay, we know the standard Fourier transform pair. Signum of t Fourier transform is 2 by j omega. So apply duality property to this pair. 2 by jt Fourier transform is 2 pi into signum of minus omega. We know that signum is an odd function. So 2 by jt Fourier transform is minus 2 pi signum of omega. So 2 gets cancelled and get pi this side. So j that side. So 1 by pi t Fourier transform is minus j signum of omega. But in the problem asking 5 by 2 t. So phi by 2t Fourier transform is 5 pi by 2, if pi go this side, and minus j signum of omega. So this is equals to minus 2.5 j pi signum of omega. This is the answer. So answer is C, minus 2.5 j pi signum of omega is the answer. The question is, what percentage of total energy in the signal f of t equal to e power minus t into u of t is contained in the frequency band mod omega less than 7 radians per second. Okay, first let us find the total energy in the signal. So the total energy in f of t is equals to minus infinity to plus infinity mod f of t whole square dt. Signal multiplied with u of t. So integration 0 to infinity e power minus 2t dt. If you solve this integration, you are going to get 1 by 2. It is the total energy in the signal. In the same way, from the Parseval's theorem, so what is the energy in the frequency domain is, energy in f of omega is 1 by 2 pi minus infinity to plus infinity mod f of omega whole square d omega. Omega ranging from minus infinity to plus infinity. F of omega is the Fourier transform of f of t. So what is f of omega? Fourier transform of e power minus t is 1 by 1 plus j omega. What is mod f of omega? 1 by square root of 1 plus omega square. What is mod f of omega whole square? 1 by 1 plus omega square. But he is asking the energy contained in minus 7 to plus 7 omega range. So the range minus 7 to plus 7, the energy is 1 by 2 pi integration minus 7 to plus 7 1 by 1 plus omega square d omega. So this is equals to integration of 1 by 1 plus omega square is tan inverse of omega minus 7 to plus 7. So this is equals to 2 tan inverse of 7 by 2 pi. So tan inverse of 7 by pi. If you solve this, you are going to get 0.455. It is the energy contained in the range of minus 7 to plus 7. He is asking the percentage. So the percentage of energy is equals to 0.455 by what is the total energy? 1 by 2. So 0.5. If you solve this, you are going to get 91%. So the answer is B is the answer. The question is magnitude and phase spectrum of a signal x of t given, then what is the value of x of t at t equals to 1 by 2. So magnitude and phase spectrum is given. So from this, first to find x of omega. X of omega is equals to mod x of omega e to the power of j angle of x of omega. This is equals to mod x of omega is 2 from minus pi to pi, but phase is minus pi by 2 from 0 to pi and pi by 2 from minus pi to 0. So divided into two parts. First I am writing 0 to pi. Magnitude is 2 e to the power of minus j pi by 2. This is from 0 less than omega less than pi, and 2 e to the power of j pi by 2 for minus pi less than omega less than 0. So x of omega is equals to e to the power of minus j pi by 2 value is minus j. So minus 2j for 0 less than omega less than pi, e to the power of j pi by 2 value is plus j. 2j for minus pi less than omega less than 0. So from this, first to find x of t. So x of t is equals to inverse Fourier transform 1 by 2 pi minus infinity to plus infinity x of omega e power j omega t d omega. Substitute 1 by 2 pi into integration minus pi to 0. What is the value? 2j. 2j e power j omega t d omega plus 0 to pi minus 2j e power j omega t d omega, that is equals to 2j by 2 pi into e power j omega t by jt. So limits are minus pi to 0 minus e power j omega t by jt 0 to pi. So this is equals to 2j, this is pi, sorry. So 2 cancel and jj is also cancel. So 1 by pi t into, if you substitute the limit, 1 minus e to the power of minus j pi t minus of e to the power of j pi t minus 1. So e to the power of minus into minus plus. So 1 by pi t into 2 minus 2 cos pi t. So finally the signal is 2 into 1 minus cos pi t by pi t. This is the signal. Now in the problem, the value, what is the value of the signal at t is equals to 1 by 2. If you substitute t is equals to 1 by 2 here, x of 1 by 2 is equals to, if I substitute t is pi by 2, cos pi by 2, cos pi by 2 is 0. So 1 minus 0, 0. So 2 divided by pi by 2, this is equals to 4 by pi. So the value of 4 by pi is 1.273. This is the answer.